Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we're going to be learning about three important sets of numbers for mathematics: square numbers, cube numbers, and prime numbers. We'll be starting with square numbers. So, what is a square number? A square number is a number that's created by a whole number multiplying itself. So, you might start with the smallest 1 times 1, which is 1. However, we're actually going to go even smaller than that and start with 0 times 0, which is the smallest square number, 0. Then we'll do 1 times 1 and we'll work our way up the list. This will be important for later on in maths. So 1 times 1 is 1. 2 times 2, or 2 squared, is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. 6 squared is 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. So I'll pause here just to say, you should already know these numbers because of your times tables. If you've watched my previous videos on the 13, 14 and 15 times table, you'll be able to do a bit more. So 13 squared is 169. 14 squared is 196, and 15 squared is 225. So this list I would recommend remembering. That way, when you see these numbers come up in a question in your Key Stage 3 exam papers, hopefully you'll see the number 169, for instance, and think, that's a square number, that might be useful for later on. So we just need to be able to recognize that these are square numbers. Now, if you want to challenge yourself, let's go a bit further. So 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And the toughest one of all, 20 squared, let me think about that, 400. I'm just kidding about that last one. So, these are the list of numbers if you really want to challenge yourself and recognize that these are square numbers. Now, a pattern that some of you eagle-eyed viewers might have noticed is that the square numbers seem to alternate if you look at their last digit. So starting with this, we have 0, 1, 4, 9, 6, then 5. And then the list reverses itself because now we have 6, 9, 4, 1, 0. And then again, 1, 4, 9, 6, 5. And then 6, 9, 4, 1, 0. And this property is just because when you do multiplication, and let's say you're doing your column multiplication, the last digit of the answer comes from the last digits that you're multiplying together. So there's only a few combinations you can have of that, and we've just gone through it, so there's very limited numbers that they can end with. Alright, let's move on to cube numbers now. Alright, moving on to cube numbers. What's a cube number? A cube number is simply a number created from a whole number multiplied by itself 3 times in a row. So for instance, 1 times 1 times 1 is 1. That's 1 cubed. Now what's the smallest cube number? Is it 1? Well, if you were paying attention earlier, you'll know it's 0. 0 times 0 times 0. So we're going to start with that. Then we'll do 1 cubed, which is 1. And next, 2 times 2 times 2, or 2 cubed, is 8. Then, 3 cubed is 27. 4 cubed is 64, and 5 cubed is 125. So I've paused at the number 5 because these numbers pretty much are the ones that you need to remember. However, if you want to challenge yourself yet again, we'll carry on. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed, let me think about this, must be 1000. Okay, I promise I'll stop doing that now. So if you want to challenge yourself, make sure you can recognize that these numbers are cube numbers. And then you know which number is cubed, which creates them. Alright, so those are the first two lists, square numbers and cube numbers. Now we're going to move on to arguably the most important set of numbers, prime numbers. Alright, what is a prime number? Now this is a really important definition to remember. Some of you might have heard of prime numbers already, and I'm going to guess that if I asked what is a prime number, and your response would be something along the lines of this. A prime number is a number that can be divided by 1 and itself. Okay, I'm going to write that on the board. So, your definition might have been something like this: a number that can be divided by 1 and itself. Or something like the factors are only 1 and itself. So then if I ask you, using that definition, what is the smallest prime number? You might then say that the number 1 fits that definition because 1 can be divided by the number 1, and it can also be divided by itself with no remainders. So according to this definition, 1 is a prime number. However, it isn't. 2 is the smallest prime number. 1 is not. How come? Well, this definition is lacking something. I'm going to rephrase it by adding on one extra stipulation. Alright, here we go. Alright, here is the revised definition of a prime number. A number with exactly 2 distinct factors, 1 and itself. So what does this word distinct mean? All it means is that the numbers have to be different. So the number 1 and a different number. That's it. If we look at that definition, now the number 1 doesn't fit that definition anymore, because 1 can be divided by the number 1, and it can be divided by itself, which is the number 1, but those two numbers are not distinct. Therefore, the next whole number is the number 2, which does satisfy the definition. So, we'll build up our list now of the prime numbers that you'd be expected to recall and remember in your exam. Starting with the number 2, then is the number 3. Then we have the number 5, 7, 11, 13, 17, 19, 23, 29, 31. I'll pause there. Pretty much these are the numbers that we're going to be needing for our Key Stage 3 exam questions. We can challenge ourselves and go on a bit further. However, for the purposes of this video, I'll let you do that for yourself. What I want to do now is point out something interesting in this list of prime numbers. The first thing is that there's only one even number in this list, and that's the number 2. The smallest prime number is also the only even number in the list. The second thing I want to point out is that prime numbers, after we've gone past single digits, so 11, 13, 17, 19, and so on, we will never find a number ending in 5. And if you've watched my previous video on divisibility rules, you'll know the reason is because numbers ending in 5 have a factor of 5. Or 5 can come into them exactly with no remainder. Or they're in the 5 times table. Take your pick. The point is, from that point onwards, prime numbers will only end with 1, 3, 7, or 9. And that's it. So, what did you think of the video? Make sure you give it a like, comment, and subscribe if it helped you out. Good luck in your exams. Take care.